The next lesson is titled Law of Sines. In this lesson, we'll look at given different information, how to utilize a new set of formulas to solve for missing side lengths and angles in oblique triangles. Law of cosines is going to be just formula-based like law of sines was. If we were given two angles and a side, or two sides and an angle, we used law of sines. Law of cosines is just based on different given information or the order that it's given in. You'll have three formulas that deal with finding side length. And you'll notice they're quadratic. You either have a squared, b squared, or c squared that you're solving for. You'll have to take the square root to find the length of the specific side. There are also three formulas for angle measure. And notice to get A, B, or C by itself, you'll have to take cosine inverse. The nice thing about that is we'll only ever have one possible right triangle, or one possible triangle when we solve these. It says only one, well, I just said that, didn't I? Only one triangle is possible using law of cosines. Remember our rounding rules. We will round to the nearest tenth. That does get us into a little bit of trouble. The unique thing with cosines is that sometimes you need to round to the nearest hundredth to get the angles to equal exactly 180. So if we keep our rule the same as before, just for consistency, sometimes the angles in a triangle, they won't always add up to exactly 180. So sometimes the angles won't add to exactly 180. And we'll have to just be okay with like 179.9. All right, so just keeping that in mind. You'll use law of sines when you're given a couple of different scenarios from 8.1. One option is if you're given all three sides and no angles at all. So if you know your connection is side, 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 you would use the angle or the angle formulas in blue at the top. Plug in what you know for side lengths and then take the inverse. The other situation is if you have two sides and an angle in between. So that's side, angle, side, different from side, side, angle in day one. What this will help you do is find the length of that opposite side using the formulas with the red up above. We'll look at one of each type of examples. Starting with triangle ABC on the left. Notice we're given side length A, which is 6, side length B, which is 12, and side length C, which is 8. So we're given side, side, side. That means we have to use the formulas up in blue on the right to get the angles. And the big takeaway with that is the angle measure is always directly across the opposite side. Whoa, this is kind of trippy. Notice angle A in that formula, and it's minus A squared. B minus B squared, C minus C squared. And then the other variables just are adding, and then they're in the denominator for that fraction. All right, let's take it back to that problem. Hang on. Whoa. All right, here we go. To find those angle measures, this is what we do. We'll start with angle A. If we're going to find the measure of this angle, we would write cosine A equals. And then the order is b squared plus c squared. And you could really interchange them. It wouldn't matter their order because you're adding them anyway. But we'll write it out like they want us to. The key takeaway on this is now it's minus a squared. All divided by 2 times the length of b times the length of c. And what we're going to do here is just leave this in fraction form. If you plug into your calculator 12 squared plus 8 squared minus 6 squared, you would get 172. In the denominator, if you take 12 times 2 times 8, you would get 192. To get angle A by itself, we simply take cosine inverse. And we'll just plug in that fraction. Cosine inverse of 172 divided by 192 for angle A would give that angle a measure of approximately 26.4 degrees. You guys try the next one. I know it seems a little early, but I think you can do it. See if you can find the measure of angle B by following the definition up above, plugging in the side lengths you know. Then press play and see how it went. If you follow the formula, you should end up with cosine of B equals negative 44 over 96. Taking the inverse of that negative fraction, the measure of angle B is approximately 117.3 degrees. And now here's where we have to have that conversation again. If you know two angles, to get the measure of the third, technically, yes, you could subtract from 180. But because we're rounding to the nearest tenth, not every angle or not every triangle will add up to exactly 180. So this is a situation where you are going to want to go back up to the formula to try to find cosine C by plugging in the definition. Go ahead and try that one more time, and then we'll move on to the other example. You should end up getting C is approximately 36.3 degrees. If we added up angle A, which is 26.4, angle B, 117.3, and angle C, 36.3, we would in fact get exactly 180 degrees. However, it's not always true, as we'll find in the next example. Once again, we have triangle ABC. We're given angle A, we're given side B, and we're given side C. So we don't know lowercase side length A or angle B or angle C. Because of that, taking a look at the formulas up above, we're going to look at the side length formula and get the length of A first. Once again, here we go. If you look at that formula up above, notice the similarities to the formulas for angles. The side length on the left matches with the cosine angle on the right. Side length on the left, angle on the right, side length, angle. As long as you remember that, the A's, B's on the right-hand side are interchangeable because we're actually just adding them together. All right, let's bring that information back down here to triangle ABC. To find the length of A, the formula is A squared equals B squared plus C squared minus 2 times BC, so that would be 12 times 16, times cosine of angle A. And angle A is 80 degrees. Now what I want you to do is actually just plug that all in at once. We're not going to do any parts on this, just plug it all in together. Oh, can you hear those birds out there? When you do, we get A squared equals approximately 333.3 to the nearest tenth. To get A by itself, we'll take the square root of that. The measure of side A to the nearest tenth is approximately 18.3. And that's all we do with that, 18.3. And now we went from side angle side to knowing all three sides. To get cosine B and cosine C, we'll apply the angle formulas up above, just like the last problem. Start with cosine B. If we do A squared plus C squared minus B squared all over 2 times A times C, we would get cosine B equals 446.89 divided by 585.6. To get B by itself, take the inverse. So not too difficult of a process. If you can write the right numbers down, that's always good. And angle B to the nearest tenth is approximately 40.3 degrees. And again, if you were to take these two and subtract from 180, you would get a different angle by subtracting than we will if we take cosine C and write out its definition. So that's why it's pretty important to just follow the steps that we do in the notes and not try to take any shortcuts. This is an example where that wouldn't work out for you. To get cosine of angle C, we would do A squared plus B squared. And it's because of this decimal right here that really throws us off. And then we would subtract c squared divided by 2 times a times c, b. That would give us cosine c equals 222.89 divided by 439.2. And then we take the inverse. And again, these will all be in degree mode, so there's no need to worry about changing that up at all. Over 439.2, all in there, parentheses. And now we get angle C is approximately 59.5. Not 59.7 like you would have gotten if you subtracted from 180. And yes, I will mark for that. So if we're rounding to the nearest tenth, make sure you've rounded correctly. We'll end today's lesson with a little bit of application and save that area formula for Monday. It says 2 airplanes leave an airport at the same time. An hour later, they are 376 miles apart. If one of the planes traveled 298 miles and the other 235, find the angle between their flight paths. So you're asked to simply find this angle where the airport is. Think of that as like angle A. And then treat side length A directly across, and B and C can be either other order. That part really wouldn't matter. There's a C right there. So if we're trying to find our angle, we're going to use the formula options on the right on your formula template on the last page. Cosine A equals, we'll say B squared minus C squared. So these are going to be kind of big numbers. 289 squared plus 235 squared. And then we'll subtract out the side length directly across the angle, 376 squared. All over 2 times B times C, so 2 times 235 times 289. If we enter the top into our calculator, we actually get a negative answer. Negative 2,630. The denominator, we would get 135,830. If that's the cosine fraction, we'll take the inverse to get our angle measure. The cosine inverse of negative 2,630 divided by 135,830. Now this is a degree answer. We'll round to the nearest tenth. If you enter that into your calculator, you should get approximately 91.1 degrees. That would be the angle between their flight paths. And that's it for 8.2. Submit your notes today for credit, and tomorrow you'll get an 8.2 worksheet.